Hi, hello everyone. For introduction to physics group assignment, we gangs of Supernova going to explain about land transportation. We are going to explain more and more interesting contents about this.
In our daily lives, we are surrounded with physics here and there. It is all depends on us, either we realize it or not. Let's say land transportation. Sure, we all use transportation to get us where we want it, for at least must be once a week, I assume. There are plenty of physics concepts in land transportation. As of that, me and my groupmates are going to present to all of you the physics in it and the differences between old and modern vehicles. Death rate caused by road fatalities in Malaysia has decreased over the years, thanks to the invention of crumple zones. How do they work? Early designs of car bodies were designed to be rigid, without much regard for what happened to the car and its occupants in a crash. That is one of the differences between old and modern cars, their bodies. In a crash, crumple zones help transfer some of the car's kinetic energy into controlled deformation, or crumpling, at impact. This may create more vehicle damage, but the severity of personal injury likely will be reduced. Crumpling allows the vehicle to take a little longer before coming to a stop, in effect lowering the average impact force and increasing the survival space for the belted passengers.
Hi, hello everyone. I'm Arvind Kumar Munusami. As a beginning of this presentation, I'm going to talk about how past vehicles produce more sound pollution compared to nowadays vehicles. One of the major reasons why nowadays vehicles produce less sound pollution is because of aerodynamics. Automotive aerodynamics is the study of the aerodynamics of road vehicles. Its main goals are reducing drag and wind noise, minimizing noise emission, and preventing undesired lift forces and other causes of aerodynamic instability at high speeds. Air is also considered as a fluid in this case. In the evolution of aerodynamics, the shape of cars has changed, often in very subtle ways, in order to reduce drag and thus increase both cars' fuel efficiency and performance. But an additional benefit of this has been a great reduction in wind noise that makes the cabin much quieter on modern cars than in the past. Other than aerodynamics, we could also say hydraulic valve filters and roller tappets as a main reason. In the past, many engines and all high-performance engines employed solid lifters to transmit the motion of the camshaft through the rockers to the valve. This allowed more precise and quicker valve actuation, but they could not compensate of the expansion and contraction that occurs when an engine goes from a cold startup normal operating temperature. When the engine was cold, there would be a gap between the component parts. This would cause a mechanical clicking sound. Modern hydraulic filters eliminate this sound. So thank you guys, that's all from me. My partners will explain more about land transportation in coming slides. Thank you.
Hi everyone, my name is Kai Kwan and I will be talking about air pollution between past vehicles and modern vehicles. Before I do further explanation, let's watch a video together.
Air quality and climate change are two of the biggest challenges facing society. They're issues the motor industry takes very seriously. That's why we're spending billions on new technology. As scientists have learned more about air quality, so we have responded. We've built the cleanest vehicles in history using the latest Euro 6 technology. Today's cars are light years away from those of the past. Modern diesel cars have saved 3 million tonnes of carbon dioxide emissions since 2002. Cut nitrogen oxide emissions by 84% over 15 years. And virtually eliminated soot particulates. 1 in every 3 cars on British roads is a diesel, and we're leading the way in cutting nitrogen oxide emissions in Europe. From electric and hybrid to hydrogen, we're creating new technologies for the future, and demand has grown more than 40% since last year. Whatever fuel you use, New vehicles must, by law, pass strict air quality and emission tests under controlled lab conditions. Every new car must meet the Euro 6 air quality standard, and manufacturers must also publish their carbon dioxide results. But this test is about to get even tougher. From next year, new cars will, for the first time, be tested on the road. Our industry is delivering real-world reductions in emissions and improved air quality now and for the future.
So from this video, we knew that car emissions from the past is better now. It's if compared to from the present is better than in the past. So nowadays, this Euro 6 technology should be applied in Malaysia to reduce the air pollution in Malaysia. That's all from me. Thank you.
Future of cars, self-driving car. Cars today already include many semi-autonomous features like assistant parking and self-braking system, and completely autonomous vehicles which are able to operate without human control are rapidly become more of a reality. So what makes self-driving cars see? There are three technologies help self-driving car observe surrounding: ultrasonic sensor, radar, and LiDAR. Ultrasonic sensor. They can follow obstacles such as car, pedestrian, buildings, and they are useful for blind spot detection and parking. It's sending out a sound from a loudspeaker and receive it with a microphone. It's cheaper among the three, but is sensitive to the temperature and humidity. This is the common position for the ultrasonic sensors and the area they can sense. The second one is the radar. Radar is short for the radio detection and ranging. Long-range radar found vehicles in distance like 100 meters and more ahead. The short-range radar provides awareness for close traffic and blind spots. It can detect the distance from car to the object and their speed through the droplet effect. It is resistant to the light gravel, flood, snow, and dust, but it cannot provide high information. Its output only two-dimensional map. Second one is LiDAR. LiDAR is similar to the radar but is using light. It can provide 3D data but it needs multiple beams up to 64 for some unfavorable weather. It cannot provide accurate speed measurement unlike ultrasound and the radar. So this is the three technology help self-driving car observe surrounding, and that's all.
Hi, my name is Sang Ho Ying. I will explain the efficiency of the vehicle in the past and now. As we all know, modern cars are more efficient than older cars. Burning fuel like gasoline is not efficient. Of all the potential chemical energy, only 10 to 30% is converted into power that moves the car. Another 17 to 90% of it converted to heat energy and friction. To overcome this problem, modern engines use direct injection technology. Fuel is directly injected into cylinder. It does not mix the fuel and air before reaching the cylinder like older engines. Another way to increase the efficiency is by using turbochargers. Turbochargers use exhaust gas to power a turbine that pushes extra air, which is oxygen, into the cylinder to increase efficiency. To compare the vehicle in the past and now, let us take Proton Saga as an example. As we can see from these two pictures, 2016 Proton Saga is more efficient than 1985 Proton Saga as it has higher horsepower and it also consumes fewer fuel to move 100 km.